So for this particular video, we're going to be looking at something that you already know a little bit about from one of the previous videos. Talked about the parent graph of a quadratic function. Now, the parent graph, they graphed it using a t-table, and what you ended up knowing was that the vertex was at 0, 0, the x-intercept was at 0, 0, and the y-intercept was at 0, 0. And that is why you had to use the t-table to graph this one, because all those are the same point, which is the origin. So using the t-table, knew that x and y, when x was -1, y is 1, x is 0, y is 0, x is 1, y is 1, x is 2, y is 4, and so on. And the graph ends up looking like this. Here's 1 and 1, -1 and 1, and then 2, 4, and then we talked about how there are points that reflect over the axis of symmetry. So you can see that this point right here that I'm talking about at 2, 4 has a reflected point across the axis of symmetry that is -2, 4. So that allows us to sketch the graph. Now, everything that we do is actually coming off of this parent graph, and we're going to talk about the translations of the parent graph as we go through this unit. But right now, I want to focus on this one on the left. Y equals -x squared. Now, we're going to do a t-table for this one as well. And I want you to think about what's going to happen with this negative sign. All right? So when we do the t-table, we're going to do the same ones. We're going to do -1, 0, 1, and 2. So when we put -1 in, so I'm just going to erase this up here and I'm going to plug in above it. So y equals -1 squared. We have to do the exponent first. So you end up with y equals -1. So that's different from what the other one looked like. So when x is at -1, y is at -1. So I'm going to switch colors. All right, you plug in 0, it's still 0, which is right there. Plug in 1, you're going to get the same thing we did over here. So, show you again, y equals -1 squared. That gives you -1. We plug in 2. Now this gives you 2 squared is 4. Then you have the negative sign on the outside, so it's -4. So I'm going to go to 1, -1, and I'm going to go 2, -4. And I still have the same axis of symmetry, so I can reflect my 2, -4 over the axis of symmetry and go over 2. And our graph has completely changed, and it's all due to that negative sign. That negative sign caused us to have a reflection over the x-axis. So what you need to know about this as a reminder, when a is greater than 1, or greater than 0, I'm sorry, when a is greater than 0, not equal to 0, we can't be equal to 0, but when a is equal or is greater than 0, your graph opens up. When a is less than 0, meaning that it is a negative number, your graph opens down. Okay, so we're going to be talking about what happens when we change pieces of the graph as we go through and as we change pieces of the function. So just one more thing that I want to add to this, and that is how many x-intercepts can you have? So I've color-coded these. Let's start with the first one in red. We have -x squared plus 1. Here is my graph of -x squared plus 1. All it's done is shift up 1. So how many x-intercepts does this one have? So negative x squared plus 1 equals y has 2 x-intercepts. All right, now, looking at the green one, this is our parent graph of y equals x squared. So you can see the graph here. How many x-intercepts does it have? Well, in this case, it is sitting on the x-axis. So y equals x squared has 1 x-intercept. And then finally, look at the blue one. Y equals x squared plus 4. That's this graph here. You can see that it is above the x-axis and it is opening up, and it never crosses the x-axis. So y equals x squared plus 4 has 0 x-intercepts. All right? Now, this is going to become important when we talk about how to find more information about the x-intercepts and how to determine without graphing if you're going to have 1 x-intercept, 2 x-intercepts, or no x-intercepts. So go answer the questions and make sure you submit them.